Hello everyone, I am Harshita Khandelwal. Today I am here to explain the load frequency control. In load frequency control, first we need to know what is the load frequency control. In electrical power system, load frequency control (LFC) is the system to maintain the reasonable uniform frequency, to divide the load between the generators, and to control the tie line interchange the schedule. To meet with the vastly varying load demand and to maintain the stability of the system, load frequency control is mandatory. So, our topic is turbine speed governing system. To understand the load frequency control, let's consider the steam turbine speed governing system as shown in the figure. Here is a systematic diagram of the speed governing system. In this, we are having the so much components. The main components are flyable speed governor, hydraulic amplifier, linkage mechanism, and the speed changer. First, we need to understand the concept of the turbine speed governing system. We need to control the power output. Our aim is to control the power output, so we need to control the frequency. That is generally we give the 50 hertz frequency, and we can have the modified changes in the frequency, that is point plus minus zero point 0.5 hertz. So because to control the power output, we need to control the frequency also, because we know that power is equals to torque into omega. So first we need to understand the components of the governing system. Pliable speed governing system. We can say that it is the heart of the system, and it is responsible to detect the change in the speed that is given by the speed changer and the integral controller. Okay, then second one is the amplifier, hydraulic amplifier. It possesses the a pilot valve, and the second one is the main piston arrangement. It is the arrangement. It converts the low power level pilot valve to high power level piston movement. We need to understand the concept behind this. So this is the hydraulic amplifier. We are having the pilot valve at the top of the system, and the main piston is here. So here is the high pressure oil inserted in the hydraulic amplifier. We need there are the valves in these valves. We are having the flood in this hydraulic amplifier. And the third mechanism is the linkage mechanism. We are having the two linkage mechanism, ABC, and the second one is the CDE. ABC is the rigid link pivoted at the point B, and CDE is the another rigid link pivoted at the point D. They provide the movement to control the valve in form of change in speed, and gives the feedback mechanism through the steam valve movement. So in this we can understand the speed change in the speed is given by the control valve to the linkage mechanism. So it is the del ns is the speed, and the del f is the change in the frequency. It is given by the linkage mechanism. And the fourth one and the last point is speed changer. Speed changer is it provides a steady state output setting. It provides a steady state output setting to the for the turbine. It downwards movement opens the pilot. It downwards movements means the speed is increases, and the pilot valve will open, and the main piston will comes outwards, and the steam no sorry main piston downwards, and the speed will come inside the turbine. So if speed changer comes outwards means it pilot valve will not open. So if pilot valve will not open, then main piston will be comes downwards, and the steam cannot enter in the turbine. So we are changing the speed. So we know that ns is equals to 120 f by p. If we change the speed of the system, as take the example, if we change the speed, and the frequency will also be changed, and if we increase the speed, and frequencies will be also increased by this formula, and we can take the reference to understand the concept of the speed changer. So next is speed governor model. In this, from the linkage movements, we can understand, and we can get the xe is equals to k1 del f minus k2 del into pe. and the second one is the del of xd is equals to k3 into del xc plus k4 into del of xe. So, but total volume entering in the cylinder is del of xe is equals to k5 integration of minus of del of xd into dt. So, on solving these equations, we will get the position change in the linkage E. So, this will give by this form, this equation del of xe is equals to gsg into del of pc minus del of f by r. Pc is the commanding increase in the power and del f is the change in frequency. So by we can understand by this formula the block diagram of the turbine speed governing system. So we are having this adder they there we are putting the commanding increase in the power in the adder, and we are having the change in the frequency. So we will get the this transfer function. In this gsg is the transfer function of the speed governor, and kg is the gain of the transfer function, and p del of pc is equals to commanding increase in the frequency, and del f is the change in frequency. So by changing the frequency, we can understand by this diagram. So that we will get the steam and steam to the turbine. Yeah, here we are having the load, and we are having the frequency sensor. Then this will detect the frequency, means change in frequency, and it will give the indication to the adder. It will give the generating frequency, and we are having the set frequency. So if there is a difference in the set frequency and the generating frequency, it will give the indication to the integral controller, and this will give the feedback to the speed changer, and speed changer will give the change the indication to the fly ball, and it will control the speed. So by this we can understand the spin turbine speed governing system. Thank you so much.